What if an AI could predict a life-threatening condition hours before any human doctor even sees the signs? Well, that's not science fiction anymore. It's actually happening in hospitals right now. Welcome to your February 6th Health Tech Dose. Today, we're going to cut through all the hype and see how AI is really changing the game at the patient's bedside. We're going to explore the incredible promise, the messy reality, and, the path to actually getting it right. And look, this isn't some far-off forecast. This is a reality check. As this quote from a brand new Stanford-Harvard report makes crystal clear, AI isn't on the horizon anymore. It's already here. It's woven right into the fabric of our healthcare system, from how you check into a hospital to the health apps right there on your phone.
Okay, so what does this clinical boom actually look like on the ground? We're not just talking about one or two flashy apps in a research lab somewhere. No, we are talking about a fundamental shift in the day-to-day work of providing care. It's reshaping pretty much everything, from how we diagnose to how we do paperwork. The best way to think about it is like AI is this invisible partner working right alongside our doctors and nurses. It's the co-pilot flagging a patient who might be taking a turn for the worse. It's that second pair of expert eyes helping a radiologist spot something on a mammogram. And it's the tireless assistant that tackles that mountain of paperwork that just burns everybody out. So it's not just another tool. It's really becoming a core member of the care team.
But what's the real promise here? I mean, beyond just making things run a little smoother. Well, it's about seeing human biology with a kind of precision that we've just never had before. A precision so powerful, it could totally change how we even understand disease itself.
Okay, check this out. This example from a Stanford study is just stunning. For decades, prematurity was kind of this catch-all label based simply on a baby's birth date. But then AI comes in. By analyzing metabolic data from these tiny little blood spots, researchers discovered it's not one condition at all. It's actually several totally distinct biological states. I mean, that is a profound shift. We're going from a simple calendar date to a deep biological fingerprint. It's the difference between asking, when were you born, and asking, what is your body actually telling us?
And that right there, that brilliantly illustrates this massive shift. You could call it the death of the sketch. We're moving away from these subjective observations and into an era of objective, machine-level data, where we can see biology with a clarity that honestly was once just unimaginable. But, and this is a big but, this is where the clean, pristine world of data science collides with the messy, unpredictable reality of a hospital. What happens when these incredibly precise tools leave the lab and meet the beautiful chaos of clinical practice? Well, this is where we run into something called the reality gap. And that Stanford-Harvard report really frames the central question we all have to be asking. I mean, it's one thing for an AI to look like a genius working with a perfect, clean data set in a lab, but real-world medicine isn't clean. It's complicated. It's human. And the report shows there are some pretty critical gaps between what AI promises and how it actually performs in the wild. So the first and most fundamental challenge is something we can call the hardware gap. Because let's be real, an algorithm, no matter how brilliant it is, can't physically give a patient a drug or comfort them when they're scared. Software alone cures nothing. And when we say hardware, don't just think about computers and servers. It's the entire physical ecosystem that the software needs to actually have an impact. It's the wearable sensors that collect the data. It's the smart tools like that smart cloth prototype that can assist with care. And of course, it's the actual medicines that treat the conditions the AI spots. Yeah, this quote just hits the nail on the head. You can have the most powerful predictive software in the entire world, but without the sensors to collect the right data and the physical treatments to act on its insights, it's just code. The real magic, the real breakthrough, happens where that brilliant software meets effective hardware. So that brings us to the second massive hurdle, the trust gap. And this is perfectly captured by the black box problem. So imagine this. An AI alerts a doctor that a patient is at super high risk for sepsis, but when the doctor asks why, the AI basically just shrugs. Now, would that doctor start a powerful, risky treatment based on a recommendation they can't understand? Not likely. If there's no transparency, there's no trust. But here's the good news. This is not an unsolvable problem. A model called Dynagraph, which was featured in NPJ Digital Medicine, basically cracked this code. And it worked precisely because it wasn't a black box. It could show doctors the exact data points, and this is crucial, the rate of change in those points that triggered an alert.
In other words, it showed its work, which gave the clinicians the why they needed to trust the warning.
And finally, even if you solve for the hardware and you solve for the trust, you can still smack right into the implementation gap. You can have the most brilliant, transparent system ever, but if it doesn't fit into the frantic, chaotic workflow of a busy hospital ward, it's going to fail. Great tech is totally useless if it's a pain to use. Okay, so we've laid out the gaps. We've got hardware, we've got trust, and we've got implementation. The critical question now is, so what do we do? How do we build the bridges to cross these gaps? How do we get from just promising code to responsible, effective tools in the clinic?
Well, the answer seems to lie in a process called human-centered design. This smart cloth project is a perfect case study. Instead of just building a tool for users, the team built it with them, every single step of the way. They mapped out what people needed, they used focus groups to find the barriers, and they just kept building and testing prototypes over and over with real patients. And this whole human-centered philosophy, it inevitably leads you to one place, putting the patient at the absolute center of how we gather information. We're seeing this massive shift away from just relying on data from a 15-minute checkup every few months. Instead, we're tapping into a continuous stream of real-world health data, from wearables, from apps, from remote monitors, to see the whole movie, not just a single snapshot.
And make no mistake, this is not some small niche trend. Just look at this number. A staggering 94% of clinical research sites have now adopted these decentralized trial methods that rely on these remote technologies. The shift is already here, and it is absolutely massive.
Ultimately, when you put all this together, the new precision, the reality gaps we talked about, and these human-centered solutions, it all points toward a fundamental rethinking of the roles that both technology and human expertise play in medicine.
So let's be absolutely clear about the goal here. This is not about replacing doctors and nurses with algorithms. The most powerful and responsibly built AI tools, they're designed to be partners. They're tools that augment human skill, automate the tedious stuff, and empower our clinicians with insights that were basically invisible before.
And this leaves us with a really critical question to think about as we move forward. We know AI is going to keep getting smarter. It's going to get more and more capable. So as it does, how does the role of the human expert have to evolve? What becomes the new, uniquely human value that we bring to a world full of intelligent machines? Answering that, well, that's the conversation that's going to define the entire future of medicine.